So first of all, we'll be needing a few things. The first thing that will be required for doing the implementation part will be, let's say, things required to be set up. So the first thing would be to get an Alchemy account. So this will serve us as a Web3 software development platform. Okay, so this is going to be the first requirement that we'll be having. The second one would be to get a Ethereum account. Or we say Ethereum wallet. Okay, this will be using for setting up our first smart contracts. So this is where we will be sending our coins. For the first smart contract implementation. So as we know that smart contracts are not free and we have to pay some charge to set up those smart contracts on the Ethereum blockchain network. So we'll be creating an Ethereum wallet. So let's do that. But before that, let's conclude what all we'll be needing. Then later, for getting the coins, for getting some test coins, will be test coins for testing our smart contract, as we don't want to spend real coins or real money for something which is still in its development. We don't want to spend so much just for testing our network. There's no point. That would be a waste of cryptocurrency. So we'll be needing some source of some test coins for testing our smart contract program or code. For this lecture, we'll be using Gorley faucet. We need to source some test coins for testing our smart contract code. Then fourth one, we need to install VS Code. This will be our IDE for writing programs. Now the fifth one is our what else is left? Fifth one is hard hat. And few setup things. So we'll be needing all of these things. Let's quickly go ahead and install all of these things and let's move further. Let's deploy our first smart contract on the Ethereum blockchain network. Once we open alchemy.com, we'll be taken to a page like this. Let's open this once again, and here we click on sign in. Then here we putting in our credential information. Let's put some detailed information about our team. Let's just call it my team. So we just are here to set up the Alchemy account. What kind of project are you looking to build? So we are just looking to build, say, a test project for now, and we'll be using Ethereum blockchain. Let's click on next. We're just gonna be using the test account, and we can just skip this for now, and we'll just type ABC here. That's it. Congratulations, we have firstly signed up on our test platform. Let's go ahead and click on create app, and let's give this a name. We'll call this hello world, or let's make this hyphen hello world, and you can say, just type in here, getting started with smart contracts. Like that. Here I'm just gonna select the Gorilla faucet that we using for sourcing some test coins, and we click on create app. Wow, our app is successfully created. Here we can have a look at it, and we'll be needing some of these keys, but let's first get some test ETH to test our smart contract. And in the meantime, I will also install MetaMask. So this will be a wallet. MetaMask is a crypto wallet which we'll be using for sourcing our coins. This is going to be our Ethereum wallet. We have created an Alchemy account. Now we'll be creating an Ethereum wallet. And Gorilla faucet is already opened in our store. Here, we'll just click Alchemy login here. In the meantime, let's quickly install these, and just click on add to Firefox here. It will just come right here, right on the right hand side where we see the bookmarks and toolbar. It should come right here once you have installed this. Let's wait for this to go quickly open. There we have our first crypto wallet. We'll just give this a random password for now. Make sure you type it correctly, and remember that in order to later access your MetaMask account. We'll just be creating next, and I will just later back up my wallet. Here I have show my test networks, and yeah, let's get started. Here's our network which we are selecting for getting some source test coins. We'll just copy the address here. Let me just go ahead and paste that here, and let's click on get ETH, and our transaction will start coming right over in our MetaMask wallet. Now right now it says 0 ETH, 0 Ethereum, but let's wait for a little bit of time for the transaction to be reflected. In the meantime, let's go ahead and quickly install VS Code. VS Code we can install, let's just quickly type here Visual Studio Code, and we'll just click on download here. It will start downloading. Just select your version, click on download. It should open. It should be a normal setup file which you can easily install on your own. And the second one is going to be Node.js. So let's click on download here as well. The same here, let's click on install, and this should be done in a few moments. Now let's go ahead and quickly open our Visual Studio. There we have our Visual Studio, beautiful software for lots of great developments, all kinds of developments. Let's quickly open a folder. Let's go into our documents and create a new folder. We'll call this Hello World. Like that. Let's select this folder and let's open it. Let's initialize our project, and there we have. Let's create a new terminal here, and terminal is right there in front of us. Let's do mkdir, or we are here in our folder already. We have created a folder, so no need to create a directory. Let's quickly just do npm. Let's create the initialization file, which will initialize our contract, which will initialize the whole code, and we'll just make it fast. Let's just type --yes. This should quickly create the file for you. There we have our files. So it created a JavaScript object notation file, which is having the version, the description of our contract, and the main file is index.javascript. There's a script here, and there's a license to the script. Now let's go ahead and let us try to install the other software, which was known as Hard Hat. So now we have installed our Alchemy. We have created an Alchemy account, we have installed MetaMask, we have installed Visual Studio Code and Node.js. Now we are installing Hard Hat. This is an integrated development environment by the Hard Hat community guys for development, debugging of our code that is created in Ethereum. Just say remind me later. And there's a hyphen over here which I'm missing, so let's complete that. Let's wait for this to be installed. It should take only about a minute. Hard Hat has been successfully installed. Let's go ahead and try to pick this interesting debugging blockchain environment. That lets us debug and dive more deeper in our code. It's for developers, for creating your decentralized application. Helps you see your apps locally before getting them deployed onto the server. Now Hard Hat has started running, and we can see the sign over here, and it's asking that what are you looking to do. Are you looking to create a JavaScript project, a TypeScript, or an empty script? So for this project we just gonna be needing this empty Hard Hat configuration JavaScript file, and this has created that. Let's go ahead and do the AR to try to see if that has been done successfully. We can see the files here. We have successfully created a JavaScript empty file. This is an empty template file which we'll be using for deploying our smart contract here. Now before we move forward, there's an important thing which we should discuss. Now this folder, our Hello World or any smart contract folder, should have a few things, and those few things include contract folder and The second one is scripts folder. This contract folder or contract folder has our actual contract, while the script folder has a script which calls the contract file. So what will happen is whenever we run our smart contract, so firstly what will happen is there will be the script file. This will trigger smart contract. It will go into our contracts folder and execute those conditions. Now those conditions will then go into the Web 3.0 framework, where we have our API keys. Now it's important to understand how the Web3 framework comes into the picture. How will the contract get to know that it's this particular user only who has paid in, whose account is connected on that Amazon account, that it's this user only that who needs to send in the coins or who need to receive in the coins once the order gets delivered. And all of that happens through Web3 framework. Now after doing this, we will be needing our Ether.js. What this Ether.js will do is that it will actually serve as a plugin between different functionality of Web3 and smart contract. So this is all what would be done and how this code will be executed. Let's go ahead and do that. We have already created our hard hat. We have already installed the hard hat development environment and created an empty JavaScript file. And we also are going to create now 2 more folders. One would be the contract and the second one would be script. So let's go ahead and do that. So just type mkdir and contract. Now mkdir scripts. Now everything is ready. Just need to start writing our smart contract. Let's go ahead, let's get started. Let's write our very first smart contract here in our Visual Studio Code. As soon as we just create our hello world.solidity file, we just get a notification. This notification says you can install Solidity. Let's go ahead and quickly install that. It should only take a minute around to install that. Meanwhile it's getting installed. Let's start coding. First of all, what we start with in any contract is by writing the first line, wherein we specify version of Solidity which we are using in development today. So first of all, we'll be specifying the version of Solidity which we are going to use today. Right now, here today we are using version 0.7.3. So let's go type in pragma. Pragma means the Solidity version which we are going to be using. Pragma Solidity, and we'll say 0.7.3. After doing that, we'll define a smart contract. Finally, we are getting slowly but surely. Define the name of the contract, smart contract, or what we'll say is defining our contract. And how we do that? We do that by typing in contract followed by the name of the contract. It's as simple as that. So Solidity has a syntax kind of which looks kind of JavaScript. Solidity has been created as a subversion of JavaScript. It's not actually JavaScript, but it's a bit different from actual JavaScript. But there are similarities. It's like an embedded JavaScript. So this is how we define our contract. Now within this hello world, my name of the contract is hello world. We are just going to be creating a simple smart contract just to get started, just to get a bit of understanding how smart contract really works. And within this, so let's take an example. Let's create, or let's come here, and for this testing and practice purposes, let's first of all create a contract on the Bitcoin network, smart contract on the blockchain network, where a live message gets updated. Now let's take an example of a contract which we are trying to deploy on the blockchain where a live message gets updated. So we can think of it as a web API of Amazon. So let's say someone has placed an order on Amazon. Now we're talking about a decentralized and DAO, that is decentralized autonomous organization of a clone that is like Amazon, where a user places his order. Instead of paying you this bank account, he pays with his crypto. There's no Amazon, there's no support which is processing every order. Rather, it's a blockchain system, blockchain monitoring system, which is automatically sending your coins into an escrow between the buyer and the supplier. Amazon is charging a bit as a commission for an intermediary between the buyer and the supplier, and as soon as the supplier delivers the product, he gets the money in his wallet, in his Bitcoin, blockchain or Ethereum wallet. Now to think of something like this, we need a smart contract where this message gets updated in case the order comes. So the message should be updated upon the supplier's profile. On the supplier profile, supplier or Amazon seller page of the current orders pending. or this, let's say the current order which have arrived. So we are trying to create something like that in our first project. What we need to do for that is we need to create an event, or we need an event to be declared. Now that event should have the old message and our new message. So let's say this event. Now we have events in our Solidity programming languages, and what we are doing through our code is we are updating those events. So we will say event update messages, and string, there will be my old string, and here would be my new string. We'll call both as strings, as these are both strings. What we will be doing basically is we'll be updating the values inside these strings, right? Let's go ahead and do that. Let's do that quickly. We have created our old string and new string. After every line we need to end it with a semicolon. The semicolon defines that our line has ended. Now what this old string and new string will have is they will have a declared state variable that should be called as message, right? There would be a message that would be getting updated through this code. Right? So we'll be creating, or we say declared state variable that should be a message, and message should be of type string. Within that string we'll have some more things, but for now let's just create that string. We say string, and we use public, private, or internal and external. So public means something that would be publicly available, that is the buyer and the supplier both can see the message. Buyers and supplier both can see the current state of transaction. It should have that. And after that we need to initialize a constructor. What constructor are really in smart contracts are, they are used to initialize a contract's date, or we say contract's data. Whatever data is there in our contracts is initialized by constructors. They are just constructors which we can use for many different things. For now we'll be just be creating our contract, and we'll use this constructor function to initialize our contract. Now this contract is initialized. Now we'll open another curly square bracket, and within that curly square bracket, after initializing my constructor as memory, I will be updating that constructor with my message, with my init message, which is declared as a string in my memory. Initialize message will just initialize that memory that is there in our message in the following code. After that we need to go ahead and now where we begin, our constructor will go at the same indent as we are following that same indent. Inside the message their indentation has increased a bit as we are inside. Now we are outside indent. After declaring my constructor which has initialized the message, now I need to update that message, right? Now I have initialized my message, I have created the old string and the new string which would be the basis for my updation of this message. But now message has been initialized, it is there, but how will that be updated? So for that we'll be creating a function, declare a public function. Now this public function will accept a string argument and update the message with the storage variable. Now this is going to update our message with the storage variable that we are having. Let's go ahead and declare the function. Now we declare a function using the keyword function and we'll call this update. But this function update is, we want it to do is that to update that memory with my new message. And after that we'll call this public how is this going to be updated is that this is going to be updated using my string memory of that old str which I declared over here. With my message. This is like the driver code that we have at the end of every JavaScript program. Now that message will be updated with my new str, or where will that go? This will go to my new message. Then that new message will be emitted using the update message with my old message and my new message. This is how we write a smart contract. I hope you guys were able to get a brief understanding of how this contract really works. But we are not yet done. Now we need to create a file that will be connected, that we'll be using to connect to our contract on the server. And we'll do that by using npm install.env --save. What we now need to do is to create a env file. Let's say here .env. This is going to be just a file which will have the which will have two things. The first thing would be the API URL, and secondly, what this will have is the private key. Of our MetaMask wallet, from where the coins, testing Ethereum coins, will automatically be deducted. Let's go ahead, let's open our MetaMask and Alchemy. Here is the key. We'll just copy this key here and we'll paste that, and let me get that, also get this MetaMask key. I will click on here, we'll click on account details, export my private key, confirm my password, and there we have it. And there's a warning that you never disclose this key with anyone, that he or she may be able to access your wallet and your coins as well. So do be careful a bit of with your private key, guys. This is like your UPI or your CVV in your card. What we now need to install is running our contract ether.js. What we now be installing would be ether.js. What this ether.js really is that this is basically a super easy way for integrating your plugins for additional tooling and some extended functionality, like we are doing here. We are connecting our wallets. We are connecting our Ethereum wallet and the Web3 platform just by creating a .env file, which we'll be calling in our scripts folder, in our scripts file. But before that, let's not jump too ahead and let's go step by step. Let's create the save. Let's install first of all ether.js. We install that using Civ development environment and with Nomic Labs, which have created this Ethereum JavaScript development environment. We call this hard hat. The command is ethers, and we'll be installing ethers at the version would be 5.0.0 for this. This will be the version. Let's make sure that this gets installed. Let's wait for a minute for this to be installed and let's continue. Ether.javascript has been successfully installed. That's a great news. Let's go ahead now. We just need to do some changes into our configuration file and here. What we will actually be making the changes. So first of all, like here, we need to set in default network. That's right. Default network should be set to goerli, GOERLI. The second thing which should be done is we need to configure the set of networks. We'll call networks. Networks would be hard hat. The first one would be hard hat. And the second one would be goerli. That's right. And the URL. Now comes the main part of connecting our Web3 development platform. we'll be connecting this using API key, API URL, and our account will call the hexadecimal hash here. And here would be the private key of our MetaMask wallet. So that is about it, guys. We have finally developed our smart contract. Let's go ahead and deploy that. So in order to compile our contract, we type in npx and hard hat, then compile. This is how we will compile our contract. Now there are some errors here which we need to address before deploying it actually on the server. There seems to be some syntax error. Let's fix that. Let's go ahead. Just some normal things. I think we can go ahead and recompile that. And let's see where are the errors now coming. Is coming here in the 7th line. Node we have created. Let's save this. Let's save this also. Yeah, I guess the saving was the issue. And now also there is some errors. Compile. It says cannot find the module hard hat ether. Okay, let's go ahead and try to install ether.js once again. Let's go ahead and try to run this once again. Let's see if this solves the problem. In case it doesn't, we might need to be required to do this again. And it says invalid URL. Okay, now this says there are one or more errors in your config file. Invalid, delete, or undefined for hard hat config networks. Go to URL expected to find a value of type string, and 0 for network. That's okay. In your config file is this one. Let's run this one time and try to see what's the error it is showing us. It turns out that we had deployed the .env file inside our contract. Instead, it should have been outside the directory. That was the small mistake which we were doing. Let's go ahead and now compile our smart contract finally. And how would we do that? So we just use this command npx hard compile, which did compile our contract. Now instead of that, we will use npx hard run my scripts, which are here in my deploy.js or JavaScript on my network, which is goer. Okay, this is how we are going to deploy our smart contract, and it's asking whether we want to do we'll just say no here. And now finally we are deploying our smart contract on the Ethereum blockchain. Well, it was interesting, wasn't it? A few errors here and there, a few there, but we were able to get through. Now this is our contract address where our contract has been deployed. Now let's open etherscan.org. Let's copy this contract number, alphanumeric combination. Let's go ahead, let's open etherscan.io right here, and we'll just finally search our contract. Well, here it is, our smart contract right here running. Now we might want to use and save this contract number somewhere so that whenever we do some upgrades here, we are able to see that on the server as well. So we'll copy this and let's see the messages, and this is how we can see those messages here. We can connect here, and we'll use the MetaMask wallet to connect. And once we sign this, let's refresh this page. Right now it says there are no matching entries, but we see that now this is coming, so means there is some activity here. Let us move back our machine, and well, here it goes. So finally we have set it up, our smart contract. We have deployed it on the Ethereum blockchain network. We installed some libraries. We started from creating an Alchemy account, and we created an Ethereum wallet with our MetaMask here. We sent some fake coins here. You can see the balance has now been deducted. And then we tested sent some fake fake Ethereum coins for testing. We installed VS Code, we installed Node.js as well. We installed Hard Hat. We also installed the Ether JavaScript, and then we got to know what this Ether JavaScript really does to our smart contract, how this changes, and then we finally created our smart contract where the message gets updated via a web interface, that the order gets shipped. So on Amazon he will see, the customer will see orders on the way, or seller page he will see that there is an order that has arrived in your Amazon account waiting to be shipped with the customer delivery details. So that was a brief lecture, guys. How can we deploy a smart contract onto the Ethereum blockchain network? Hope this was a useful lecture for you guys. I hope to see you in the next one. Do stay tuned and happy learning.